My name is Dr. Peter Neff. I'm an assistant professor at the University of Minnesota, and I'm a former Science Olympiad competitor, just like you all are. So congratulations for making it to the national competition. That represents a lot of work that you all have done individually and as teams. So I grew up in Washington State and went to high school in Brush Prairie, Washington, where my team from Prairie High School for a number of years won our state competition and made it to national competitions. And all that work culminated in, luckily, my senior year of high school. We went to nationals and actually placed third overall, with a number of us placing first in individual events. So one of the events that I was in was bottle rockets. We made these water-powered rockets that were supposed to stay in the air as long as possible. And thanks to some great students before me, we had an awesome design, and we won first place. Fast forward a decade and a half, and I'm now an earth scientist, a professor, and I'm actually a glaciologist. I study snow and ice, and particularly the climate information we can get from drilling ice cores and studying each year's layer of snowfall going back in time. And to do this, I really apply skills that I learned starting in Science Olympiad, and those skills pertain to certainly the scientific skills that you need to do research and the interpersonal skills, but really working with teams is what my career in science has been all about. So we try to answer important questions about the Earth system, about Earth's climate and how it's changing due to human emissions of greenhouse gases. And we really can't answer those questions, especially how complex they are surrounding global warming and climate change, without working in teams, where we're working with people who have different experiences than us, different backgrounds than us, and different skills to bring to bear on these scientific questions. And I thought the best way to illustrate to you how that's played out in my career is to take you with me to Antarctica the last time that I was there, which was the winter of 2018 and 2019. So this project was at a place called Law Dome, which is directly south of Perth, Australia, in Antarctica. And it's a dome of ice that we go back to again and again for the high-resolution information that the snow and ice there preserves about past climate. And so over this period from November 2018 to February 2019, I was one of the leaders of this small scientific team, so maybe 7 or 8 of us for most of that time. And we're out there drilling ice cores to study not only greenhouse gases in the recent past, in about the past 150 years, but we were also studying how those greenhouse gases are removed from the atmosphere. Things like methane are oxidized from the atmosphere by a molecule called hydroxyl. And we don't know how that process has changed through time, so we can go back in time by drilling ice cores like this with an ice core drill, going down at this site about 240 meters deep. And you can take a trip down this borehole right now, and you can see from inside the drill, racing down the hole to reach the bottom, where we drill and we collect 1 meter of ice, rotating the drill and cutting the cylinder of ice. And each meter at a time, we bring them back to the surface. Now, there's one really special thing about glacier ice. Not only is it made of ice, but it's also made up of air that was once up in the free atmosphere. So because glacier ice is composed of a pile of snowflakes compressed into solid ice, the space between the fingers of those snowflakes traps an air sample. It's our one archive of what the atmosphere was like in the past, just frozen in ice. And so what we were doing at this site is collecting a large amount of ice that we could sample all at once. It represented a couple of decades of the atmosphere in the past. And we'd collect all these cores, clean them, surviving storms all the way, and we load them into a big vacuum chamber that we had down there in Antarctica. We put the lid on, pump out all of the modern air, and then melt that ice, which releases the old air, and we could then take that in a sample canister using some pumps, pump it from that melted ice into this stainless steel canister that's now an archive itself of old air. We had one of those tanks that held about 50 or 60 liters of air from the 1870s. And so once you do all that sampling, you have to get your sample back home to the lab to do our analysis. And that requires a combination of planes, of tracked vehicles, driving the samples from our drilling site to the coast. And once you get to the coast, you then have military aircraft that can fly the sample, in this case back to Australia, before it hops on a ship and goes all the way back to the US to the University of Rochester, where we then have that bulk sample of the atmosphere in the past, and we now want to isolate our species of interest. Here we were measuring carbon monoxide, so we had to use liquid nitrogen to freeze out most of the atmospheric constituents besides carbon monoxide and methane. Then we actually combusted the carbon monoxide, trapped it again using liquid nitrogen before sealing it off in a clean glass tube to send overseas again for radiocarbon analysis. So to get a science project like that done obviously takes a number of levels of teams applying their diverse skills to solve the problems that come up in a big months-long field project like that. So everybody from our mechanics and our field leaders to us as scientists applying skills in chemistry, math, and physics, but also the engineering of recovering ice samples, operating vacuum chambers and pumps in very cold temperatures. We all had to be ready to contribute as a team of 8 or 10 people to keep the camp running and the science moving, but then also as smaller teams, just like you all on your individual Science Olympiad events, have to work together to try to solve the problems that you're tasked with in your events, just like we had to solve the problems that our science projects throw at us every day when we're out in the field. Congratulations on reaching the National Science Olympiad tournament. It's a huge testament already to your skills and your teams. So good luck with the competition. I know you're going to learn a lot and do really well, and I look forward to having another crop of Science Olympians out in the world, hopefully pursuing careers in science.